Okay, let's dive into something pretty wild. We're going to explore a radical new framework for physics, one that challenges our most basic assumptions about the universe by completely redefining space and time. Seriously, this isn't just a new theory, it's a whole new reality. And at the very heart of this new system is this one really mind-bending question. What if we've been looking at it all wrong? What if space and time aren't the box that reality happens in? What if they are the reality itself? So, you might be asking, why on earth would we need an idea this radical? Well, to get that, you have to understand where fundamental physics is today. And for all its incredible success, there's a growing feeling that maybe, just maybe, it's hit a wall. And look, this isn't just some minor disagreement. We're talking about leading minds, Nobel laureates, who are saying, hey, we are fundamentally stuck. The feeling is that the old ways of thinking just aren't cutting it anymore, and we need a completely fresh perspective to move forward. And here is the core of the problem, visualized perfectly. Our two greatest theories in physics are built on ideas about space and time that completely contradict each other. In Einstein's general relativity, space-time is this dynamic, flexible actor that bends and warps. But in quantum field theory, it's just a fixed, passive stage. You see the problem? This is why finding a background-free theory has become the holy grail of modern physics. So what if the answer isn't to try and smash these two ideas together? What if instead we just replace the foundation they're both built on? That's the core idea behind the reciprocal system theory from the late engineer Dewey B. Larson. And this leads us to the theory's big, radical idea. The universe is made of one thing and one thing only: motion. But not the motion of something, no, just pure motion itself. Think of it like a balloon inflating and deflating. It's changing in size, but not going in any particular direction. In this view, space and time are just the two sides of the same coin, the two reciprocal aspects that make up this motion. So here's the million-dollar question, right? Can we actually build the entire zoo of particles in the standard model? The entire fabric of our reality, from this one shockingly simple ingredient? And this is the fundamental shift, the one thing you really have to get your head around. We're no longer talking about objects moving through space over some amount of time. Instead, the theory proposes that motion itself creates the very properties we measure as space, as time, and ultimately as matter. All right, so if we're going to have a new foundation for reality, we're going to need some new rules. And in this case, that means we need a whole new kind of mathematics to describe it. And right out of the gate, this new framework starts explaining things that have puzzled physicists for 100 years. Take the weird quantum spin of an electron. It has to rotate 720 degrees, 2 full turns, to get back to where it started, which is bizarre, right? Well, in this system, if you imagine a fundamental unit of motion oscillating, expanding and contracting, it naturally takes 2 full cycles to return to its starting state. Problem solved. So to actually model this, you need a new tool. You can't use the old math. You need a new kind of number, one that can hold both the oscillation of space and the oscillation of time together in one package. You start with a basic unit of motion, you let space oscillate, you let time oscillate, and then you combine them. And this diagram here, this is basically a picture of that new math being born. You can see the simple unit of motion branching out into these two distinct oscillations, one for space and one for time. And when they come together, they form this new thing called a reciprocal number. This is the mathematical engine that drives the whole theory. Okay, now for the really cool part, the big payoff. What happens when you start putting these reciprocal numbers, these little packets of structured motion together? And here it is. This is the aha moment. When you combine these units of motion using just a few simple rules, the structures that pop out map perfectly, and I mean perfectly, onto the first family of particles from the standard model. The electron, the quarks, the neutrino, they all just emerge naturally. They aren't plugged into the theory. They are a consequence of the theory. And it doesn't stop there. Take something like electrical charge. We usually just think of it as some fundamental property particles just have. But here, it gets a stunningly simple explanation. It's just an imbalance. If a particle has more space-like oscillation, it gets a negative charge. If it has more time-like oscillation, it gets a positive charge. It's kind of beautiful, right? So let's just pause and think about what this really means. We have just built the fundamental blocks of matter without using any matter at all. Particles aren't little tiny balls. They are stable, humming, three-dimensional patterns of pure motion. This new way of thinking doesn't just claim to solve problems in physics, it also wades into a deep philosophical question that really bothered Albert Einstein for most of his life.
See, Einstein was really bugged by this weird duality in physics. He knew nature came in discrete little packets. It was quantized. But his greatest theory, general relativity, was all about the smooth, unbroken, continuous fabric of spacetime. And for the life of him, he couldn't figure out how to bridge that gap.
It all boils down to this one epic question. Is the universe at its most fundamental level made of distinct countable bits, like algebra? Or is it a smooth, unbroken whole, like geometry? The two just seemed totally incompatible. And the answer this theory offers is, well, it's pretty mind-blowing. It shows how this ancient, purely numerical pattern called the tetractys maps one-to-one onto a fundamental geometric shape called Larson's cube. The discrete numbers literally provide the blueprint for building the continuous shape. The claim here is huge. It's a total unification. The discrete world of algebra, the continuous world of geometry, and the actual physics of how particles behave, they all just snap into perfect alignment. It's not one or the other. It's a new kind of geometric algebra where the numbers create the geometry. So, the ultimate answer to Einstein's riddle? The universe doesn't have to choose. It's not discrete or continuous. It's both at the very same time, because those are just two different ways of describing the same underlying reality, a universe made of pure, structured motion. And that's the thought I want to leave you with. If by challenging our most basic, fundamental assumption, the very nature of space and time, we can unlock answers to some of the biggest century-old mysteries in science, what else have we been missing?